Up until this point in our chapter, we've talked about two different ways to write the equation of a line. The first form we learned was slope-intercept form, in which we needed to know the slope of the line and the y-intercept. That allowed us to write y equals mx plus b form, which is known as slope-intercept. Then we talked about the standard form. This is where both x and y are written on one side of the equal sign and set equal to a constant. ax plus by equals c was that form. Well, today we're going to get a third form. This is called the point-slope form of an equation of a line, and it simply contains one point, x sub 1, y sub 1, and the slope. And it's written like this: y minus y sub 1 is equal to m, the slope, times the quantity of x minus x sub 1. So, for example, to write the equation of a line that passes through the point 3, negative 7 and has a slope of 2, it will simply follow this form. Y minus a negative 7 is equal to 2 times the quantity x minus 3. You've noticed we've substituted in our 3 and our negative 7 and our slope. Now we should simplify the left-hand side to be y plus 7 is equal to 2 times x minus 3. And this is written in point-slope form. Let's take a look at a few more examples. Alright, in example 1 we see that we have a spring that is 23 inches long and it has a 3-pound weight attached to it. Its length increases 3 inches with each additional pound. Think there that's the slope or the constant rate of change. Now, this is a constant increasing situation, so they're telling us that this is a linear function or a linear equation. We want to write a formula relating the spring length L and the weight W. So let's organize our variables. First of all, W is our independent variable and the length of the spring is dependent upon the weight. Now let's write one of our coordinate points that falls on this line. We know that the length of our spring is 23 inches when the weight attached to it is 3 pounds. So I know the point 323 has to be on this linear equation. Now I also know that the slope of this line is 3 because my rate of increase for each one additional pound is 3 inches. So I have a slope and I have a point x1, y1, and now I can use my point-slope form to find the equation of this line. Alright, here's the equation of my line written in point-slope form. Now I'm also asked to graph this equation. So I'm going to go ahead and put some numbers down here on my x-axis. Remember, these are the weights in pounds. And then I'm also going to list some numbers on my y-axis, and these are the length of the spring. Okay, remember the one point that we know is on this equation is 3 over and 23 up. So we'll put that right there. We also know that the slope of this line will be 3. So I know as I go over 1, I need to go up 3. So I know that these following points will also be on that line. Now if I wanted to, I could rewrite this point-slope form in slope-intercept form simply by distributing my 3 to each one of these sets of the parentheses. So I'll have y minus 23 equals 3x minus 9. And now I'm going to add 23 to both sides. And now I'll have the equation y equals 3x plus 14. Now I can see here's my slope and here's my y-intercept. I could also come back here, plot my y-intercept, and then do my rise over run to get the rest of those points. Now again, this will be a discrete graph. It's not going to be continuous because there's going to be individual points. Alright, in example 2, we're going to exercise a few steps here to become a mathlete when we want to find the equation of a line that passes through 2 points. Here's x1, y1 and x2, y2. Now this is a pretty typical problem. We want to start off by finding our slope. So to calculate our slope, we'll do our y's on top divided by the change in our x's on the bottom. Alright, so the slope of this line that passes through these 2 points is negative 2/3. That represents m. Now we're simply going to choose one of our 2 points. Let's just choose 6, 4, and we'll plug this into point-slope form. Alright. here is the equation of our line that is in point-slope form. Now we can go one additional step and we can write this in slope-intercept form. Remember, that's the y equals mx plus b. So what that means is we need to isolate the variable y. So in order to do that, we'll distribute our slope inside our parentheses again. And then we're going to add our 4 over to get y by itself. So in the end here we have y equals negative 2/3 x plus 8. There is the equation of our line in slope-intercept form, and here's the equation of our line in point-slope form. Example 3 now asks us to write the equation of a line that models this situation here. It says, suppose you know that the formula relating blood pressure, we're going to call that variable b, and age, we'll call that variable a, is linear. We want, we know that the normal systolic blood pressure is 110 for a 20-year-old and 130 for a 60-year-old. Construct a formula for the blood pressure B as a function of A. Okay, so again, keep in mind B, blood pressure, is our dependent variable, and age, A, is our independent variable. So we're going to write a set of coordinate pairs here that follow this model, age, comma, blood pressure. So for a 20-year-old, we know that our blood pressure is 110. For a 60-year-old, we know our blood pressure is 130. Now this becomes just like the previous problem in which we have 2 points, x1, y1, and x2, y2. Now let's again rewrite this just in terms of our variables a and b. A represents our x and b represents our y. So our blood pressure should be equal to 1/2 our age plus 100, which makes my blood pressure right now about 121. How old am I?